Curiosity and exploration are simply part of our DNA. What's at the top of that mountain? What's around that ridge? What's in that forest? What's across that body of water? This quest to explore things that we think might be beyond our reach or might test our courage or our abilities.
The drive to explore has been an important part in making our species as successful as it's been.
For the eyes of the world now look into space, to the moon and to the planets beyond.
2, 1.
There's no end to what we can achieve if we put our mind to it.
It's one small step for man, one giant leap for mankind.
There are other destinations that perhaps are within our grasp. I think there are a lot of surprises in store for us.
The Holy Grail that we're searching for is a planet like Earth.
Atento control, 31 descendiendo sin novedad. We are located in the array operation site at 16,400 feet.
So we are in the north of Chile, here at the European Southern Observatory, site of the Very Large Telescope. What do we do with them? We observe the universe at large, from asteroids, comets, planets, stars, nebulas in the galaxy.
In the 21st century, astronomy had to answer a very basic question: if there is another planet like our own planet.
An exoplanet is very simply a planet that's orbiting a star other than the Sun. 20 years ago, the idea of detecting exoplanets was considered to be totally science fiction and not worthy of a professional astronomer. Now, exoplanets is one of the hottest fields in astronomy and is still growing.
The potential for habitable planets
billions
outside
of planets and planetary
are
systems.
the biggest batch of planets ever unveiled.
The Kepler telescope has discovered thousands of new planets.
Small planets are extremely common.
The Kepler mission was the first mission to do a large statistical survey and has really contributed dramatically to our understanding of exoplanets.
It has essentially taught us that planets are everywhere.
Roughly 1 out of every 2 stars has a potentially habitable planet. The number of potentially habitable planets in our galaxy alone is greater than the number of people alive on Earth. And there are something like 100 billion galaxies in the universe.
All these new planets are incredibly diverse. Nature is more creative than most of the imaginative scientists out there.
For the first decade or so, the planets that were being found were large gas giants, these hot Jupiters that are orbiting very close to the Sun.
These are not habitable planets. They're more like tiny stars.
We know from the Kepler data that Earth-sized planets are also rather numerous.
Over the past 5 years, astronomers have been finding smaller and smaller planets closer and closer to the habitable zone. We call it the Goldilocks zone, where the temperature is just right.
If you're going to support liquid water, you don't want it to be too hot or too cold.
What Kepler's done is discover that most stars have planets, many are in a habitable zone, a fair number of them are Earth-sized. We have evidence now, we can move to the next step. Do those planets have oceans? Do they have atmospheres? Kepler was never designed to do that. You need a different kind of instrument, more powerful missions.
To look much more carefully at these planets. We want something like Earth.
The problem is finding a planet like the Earth is really hard. It's extremely difficult to be able to see a planet that is 10 billion times dimmer than the star.
You see, there are lots of stars here that aren't highlighted. And we know statistically there should be planets around them and many Earth-like planets. But current detection techniques are not capable of detecting small planets even around the nearest stars.
The star is much, much brighter than the planet.
This is like looking at a searchlight and trying to find a little firefly buzzing around this searchlight from a large distance, like 10 miles. One way of doing it is with a device called a coronagraph.
A disk placed artificially in a telescope in front of the sun's disk
to block the stars so you can see the planet.
Indeed, nearby stars are easier to study. We happen to be lucky. Our solar system has not one, but 2 nearby sun-like stars, Alpha Centauri A and Alpha Centauri B.
Right there, we have that bright yellow star, is Alpha Centauri. Alpha Centauri is very similar to our own sun. It's the closest star, 4.3 light year from us. So it's our neighbor.
these two stars could very well host Earth-like worlds.
It's close enough, so if you could find planets around it, you could study those planets.
We could potentially make one of the greatest discoveries of all time, another Earth-like planet. We might call it Earth Proxima. A lot of people realized that Alpha Centauri is an easy target, except for the fact that it's a binary.
So you have two stars that you have to deal with in terms of blocking their light.
That's where most people's thinking stopped.
These scientists at NASA Ames Research Center have been working for a number of years to take on this challenge.
Kepler's completed its job. It's time to move on to more capable missions.
That project is called Mission Centaur.
Mission Centaur is a small telescope to find, and if they're found, study planets in the habitable zones of Alpha Centauri A and Alpha Centauri B.
We developed a technique called multi-star wavefront control, which solves this problem. It's the key component that allows us to suppress the light from both stars.
This is a prototype of the primary mirror. The final telescope is going to be packed on a spacecraft the size of a washing machine.
The best conditions for astronomical observations are in the outer space. The problem for space telescopes, well, same problem of entire science: budget.
Space missions are particularly expensive. What they try to do is to observe many targets. By doing that, you're adding a lot of complexity and cost.
The better way to go is to study the closest sun-like stars, for which you can use a much smaller spacecraft for much, much less money.
The beauty of Mission Centaur is when you decide that the target is Alpha Centauri, all of a sudden you can optimize your telescope.
We can do it with a much lower cost and much smaller mission and do it much faster.
This is a project whose operating budget is a fraction of a typical huge budget project such as Hubble or even Kepler. We've entered a new age, and companies like SpaceX are an example of the commercialization now of space.
Space missions are getting more and more practical, year by year.
Private industry is comfortable with calculated risks. A lot of the expertise is at NASA, so it's a natural partnership between NASA and the private sector to enable this mission.
This is a program for everyone. This is a citizen science project that not only is profound in its primary mission, but potentially profound in its secondary mission.
The Earth is going to block the line of sight to Alpha Centauri half of the time. When the telescope cannot observe Alpha Centauri, we expect to offer telescope time to different people that are interested in exploring the universe. That's part of what we want to achieve with Mission Centaur, is empower people to feel like they can have access to state-of-the-art technology.
We are enabling all of this exciting science so that we can excite our kids to become the next generation of scientists and engineers who will be the drivers of the economy of the future. If we find Earth Proxima, it would fundamentally shift people's perception of what the cosmos is.
Finding an Earth Proxima would be a transformative event in the history of mankind. I would love to think that that is something that helps bring us together. It's a very unifying thing.
How could you worry about conflicts on Earth when there's amazing, awe-inspiring things like this in the universe?
I look forward with a lot of enthusiasm to new missions that take those new steps, and the sooner the better.
So I see what we're doing as part of this hopeful future where humanity expands out into the stars. It would be a milestone of the human civilization to find another planet like the Earth.